Okay, here we've got another example of exponential functions. This one is related to Newton's law of cooling, which states that a body with a given temperature T sub 1 is placed in surroundings that have temperature T sub 0, either cools or warms to the temperature T of T after a certain number of minutes T, and it's given by this formula. Okay, so the T sub 0 is the surrounding room temperature, the T sub 1 is what our initial body temperature is, and the T of T is what our body temperature will be after a certain amount of time. Okay, so we're going to use this to solve a forensic problem. Coroner arrives at a murder scene at 12 p.m. and immediately takes the temperature of the victim's body and finds it to be 94.6. So that's going to be our body temperature, the T sub 1. The coroner then takes the temperature an hour later and finds it to be 93.4. So how much time has elapsed? 1 hour or 60 minutes. And then our new temperature, so the T of T answer here, that's going to be our 93.4. The temperature of the room, it says, is 70 degrees, so that's that T sub 0, the surrounding room. We want to find out when was the murder committed. So if we plug in all the pieces, we know that the new body temperature, 93.4, after 60 minutes, so we put a 60 in for the T, and then our surrounding room temperature was at 70, the T sub 0, and the initial temperature he took was 94.6. So let's simplify this equation a little bit. We can gather the 70 over here, get it away from that, and get 23.4, condense this inside, get 24.6. Now what we have here is a nice exponential equation, so we need to isolate this e part by dividing away the coefficient of 24.6 on both sides. Don't worry about simplifying this, don't try to round it or anything, just leave that messy fraction. We're going to take the natural log on both sides, and we take that natural log because then we can take the power rule and take the exponent and put it in the front. So it's ln of this fraction equals negative 60k times ln of e. Cross off the ln of e because that's really just 1, and that tells me then that I have to divide by negative 60, and I get my k, which is about 0.0008. Okay, so now I'm going to plug that back in, and we are going to use for our T of T, we're going to use the for the T sub 1 here in this general equation, we're going to use the 94.6 because that was the body temperature he initially took minus the room temperature of 70. That's where that 24.6 comes in, and we placed our K in there as well. Okay, so the goal is, when was the murder committed? Well, what is body temperature normally when you're living? We're going to estimate 98.6 degree is the temperature after a certain amount of time. So we need to solve this new equation right here. So subtract your 70, divide through your coefficient again. We're pretty much the same steps, aren't we? Take the natural log, apply the power rule. ln of e is 1, so divide through by the negative 0.0008, and look at what kind of answer we get here. We get t is a negative 188. How can you have negative time? Well, it means prior to the time when he took that initial body temperature. So it's 188 minutes prior to noon, which would be about 3 hours, making it close to 9 o'clock when the murder was committed.